Hello and welcome back. Today on the bench for the last time is the pre-amplifier that I built some time ago and recently modified the DC heater circuit. So essentially what I did, I put an extra tip 3055 in so that it would run cooler with better heat sinking and all the rest of it. The other day I left it on for 24 hours straight, came down in the morning and it was mildly warm to the touch, so that worked. I did have a little bit of trouble in that when I first started doing some testing on it, that the fuse would blow, and that was basically the coil circuit firing too early at the wrong voltage. I don't know quite what was going off. I sort of fiddled around with it and it doesn't work, it doesn't do that anymore. Well, let's see if it works this time. Probably won't. There we go. It's working, thank giddy goodness. So today what I'm going to do, I'm just going to do a bit of testing because I can't remember all the specifications exactly, and I'm going to try and find out the output impedance. So how I'm going to do that is use this big 100k 10 turn precision pot, stick that on the output, turn it until it halves, till the voltage halves, and then we'll know that the output impedance of this is the same as the output impedance of the amplifier. That's just Ohm's law. If you've got two resistors in parallel then of equal resistance, then any voltage that you put in will be halved. So for a start, I'm just going to turn it up to sort of about 1 point, let's say 1 point, try and get it on bang on, 1.5 volts out. That'll do. That's without any load on the preamplifier whatsoever. Next, I'm going to plug in the 100k pot. The pot's now in and it's dropped a tiny bit, so that's not too bad. So now I just have to turn it down until we get 750 millivolts in theory. I've done a few turns already. And it's not going down much. Oh, it is now. Oops. Right, where are we? 6, need to go up a bit. Right, I'm going to call it there. Right, and I've got that on the resistance meter, and that's reading 0.824 or 824 ohms in other words. So if I've done my calculations correctly, that should be our output impedance, 800 ohms. Hope that makes sense. Next, I've got a couple of 100k resistors soldered across these RCAs. I'm going to put them on the output. Then run a few distortion, maximum output tests and things like that. So next I'm going to test the output voltage. We've got 1 volt going in, 1 kilohertz, and that's 9.67. Let me write that down. Might as well check the distortion at that while we're at it. Let's just knock it back to 9.5ish. 0.3%. 0.3%. Turn that down a bit. That's into 100 kilo ohms as mentioned previously. Let's see what we get at about 1 volt. Hold on, the wrong blinking thing. Alright. change the scale. Let's do it about 1.5 volt. 0.07. What's that? 1.5, wasn't it? 1.5 V 0.07. And then next I'm going to do a quick frequency sweep, so we'll knock it down to 20 Hz, set a reference. There's a 1 kHz, we'll call that 0 dB, 1.5 volts. Let's write that down, 1.5, 0 dB. Right, that's a 0 dB. Now we'll change it to 20 kHz. Hertz, and that's gone down 0.8 dB. 20 Hertz, 0.8 dB. We'll bung it up the other way now, 20 kilohertz. And that's 0.25. 20 K, 0.25 dB. Let's see where it goes. 1 dB down. Still up there. Where are we? Where's the 0 gone? Right, we'll call that 1 dB at 40k. 40k, 1 dB, minus 1 dB, isn't it? Of course. Right, my battery's rapidly running out, so I'm going to wrap it up there. Bit of a quick one this. Not been doing much recently, so forgive the lack of videos because it's been very cold in here. And I'm a sort of stuck between projects sort of situation at the moment. Thank you very much for watching. Take care of yourselves. Ta-ra for now.